Okay, I may have skipped over a point I would like to emphasize for the previous problem. And that was that in evaluating the forces in the members of this simple triangular truss, I only needed to evaluate two of the nodes. So in other words, we did point B first, and we did point A second, and then we didn't have to do point C. And I want to emphasize why that is. So in other words, we did point B first, and it was very simple because I just found, once, that is after we had the reactions. So we get the reactions first, and then once I have the reactions, the node is easy to figure out because this is 6.67 to the right, that's 6.67 to the left. It's got to be that. This one's got to be 0 because there's nothing else acting in the vertical direction. So I got this very quickly. Once I got this, I realized that member AB is in compression 6.67 kips. That's what this tells me. Member AB is in compression. Why is it compression? Because it's pushing the node, going toward the node. And so that means if the member's in compression, it's going to go 6.67 to point A. It's got to be that way. That's how we go from point to point. Figure it out at one end of the point, oh, it's got to be the same thing at the other end, because that's the way truss members work. If it just has one force in it, tension or compression, a certain amount, that's it. So we got that 6.67, and with that, this was also given here, so we knew that. We were able to simply calculate the 12 kips using the sum of the forces in the y direction. And what does this say? This says member AC is in tension. It's pulling on the node 12 kips. Well, if it's tension pulling on the node 12 kips, then at point C, what do I have? There's my free body diagram for point C. Well, it's got to be 12 kips away from the node at point C, and this one's 0. So, and these two came from our reaction calculation. So we never had to really evaluate point C because we had information from point A, we had information from point B, we put them into point C, and that's the way it is for for any triangular truss. You only have to evaluate two nodes, and then the other one comes out. So that's what I want you to recognize. Okay, so we had our shortcut method for representing trusses and the forces in each member. So I want you to do this for homework. Here's a truss down here, and all of the forces are given. So you just but all I really want you to do is get tension or compression. So use T for tension, C for compression. And I want you to list T or C for these members right here. So in other words, member AB, you can see it, that's member AB. So pause the video and write tension or compression for each one of those. Okay, so member AB pushes on node A, pushes on node B, so it's in compression for pushing. BC, it pushes on point B, it pushes on point C, it's got to be compression. KF, pulls on point F, pulls on point K, it's in tension. GI, a little bit of a trick question. It's there, it's 0. CM pushes on point C, pushes on point M, compression. HI. Pulls on point H, pulls on point I. Tension. BM. Pulls on point B, pulls on point M. Tension. Okay, the next homework I want you to do is I want you to do this one. Start by finding the reactions. Then I want you to evaluate point C and evaluate point B to find the forces in each member. So like I say, you only have to do 2 points. So I want you to do those 2 points, and then when you're done, draw the final free body diagram for each node and member. So pause the video, find the reactions, then evaluate point B and evaluate points B and C. Okay, so let's start by finding the reactions, and first thing we do is we take that, and we've done this a bunch of times, so this is downward to the left, so we're going to have downward to the left, and the vertical is 10 sine 30, the horizontal is 10 cosine 30. They evaluate to those. So I'm going to look at this free body diagram here. I'll take moments about point A, and so now I'm going to do this reasonably quickly. So this is going to be 5 times that distance, 1.68. And this is going to be 8.66 times this distance, which is 2. And this is going to be by times this distance, which is 7.17. And in terms of the directions, this is clockwise, this is counterclockwise, this is counterclockwise. Solve for by, we get that. Take moments about B. And I've got AY clockwise. The distance is 7.17. 5 counterclockwise. The distance is 5.5. 8.66 counterclockwise. The distance is 2. Solve that, 6.25. Take sum of the forces in the x direction equals 0. And we have that AX is equal to 8.66. So here's my final free body diagram. I'm going to use that to get my forces. Well, point B, I guess I can do point B without even getting the reactions, but I wanted you to get the reactions. So how do I handle point B? Well, like I say, we want to, we create our first free body diagram. There's my dashed loop. And when I do that, I'm going to have, I've got my 10 sine, 10 cosine. That's there, but then what do I show? I show FAC. Again, remember we point away from the point when we don't know, when we have a letter next to it, we don't know what it is. And we have FBC going away. And we have the given angles, 20 degrees, 50 degrees. So what I need to do, like I said, we go like that from there. And so I have to convert this FAC. Well, what do I do? This is downward to the left, so I have a downward and a to the left. FAC cosine 50 for the x, FAC sine 50 for the y. This one is downward to the right, so I have downward to the right. and it's going to be FBC cosine 20 for the x, FBC sine 20 for the right. I look at this diagram, so everything's x and y, so it's easy to do. I then take the sum of the forces in the x direction equals 0, and so I use all the x ones. There they are. Pay attention to the arrows. If the arrows go to the left, they're negative. If it goes to the right, it's positive. So I just, like I say, I'm not going to dwell on this. You can read it. You just put it into the equation. It's equal to 0. I take the sum of the forces in the y direction, so I just use my y forces. There they are. And in this case, they're all going down, so they're all negative. So I just take them right from the diagram, take them right from here, put them into the equation. They're all negative because they're all going down. Negative, negative, negative. Set them equal to 0. I have two equations, two unknowns. Put it into your calculator. Of course, we have to evaluate the sines of these angles and all that, cosines of those angles. And I get these two equations. You can do it by hand. This shows you how to do it by hand if you've forgotten. Multiply. I'm not going to go through it. Look at the video. This explains it. It's easier if you just put it into your calculator. Hopefully you have calculator that can do this, and then I get these two numbers by solving those two equations, two unknowns. So like I said, two equations, two unknowns here, solve it, and I get FBC and FAC. So that was evaluating point C. I want to evaluate point B, so I'm going to take that free body diagram, and that's going to be that. Now, I already know what that is. That's 3.64. I figured it out. How do I know? It's 3.64 tension right there. So I know that BC is 3.64 tension. It's positive. It's tension. Pulls on the point. So when I'm evaluating point B, it's pulling on that point. And so that's how I show it. 3.64 pulling on that point. And there's a reaction that we got. So the only thing that I don't know here is FAB. I take the sum of the forces in the x direction equaling 0. You can see it's not going to help me to do the sum of the forces in the y direction because this is going in the x direction. It's not going to appear in my equation. So I have to take the sum of the forces in the x direction. And of course, what do I do with this? I take the cosine of the angle. So it's going to, what I should do. I mean, you can do that in your head. I guess I could do it longhand here. Maybe I'll just show it right now. That what we're doing is we've got the the 3.64 goes upward to the left, so I have upward to the left, and then I can just write down. So this is going to be 3.64 cosine 20 degrees, and this is going to be FAB. This is going to be 3.64 sine 20 degrees. This is 1.24. So I can then look at my I can look at this free body diagram right here. Just take the x ones right there, and they're both going to the left, so they're both negative, and I simply put them into this diagram, this equation here, set it equal to 0, and I can solve that for FAB. I get negative 3.42. So now I have all three member forces. I've calculated them all simply by looking at those 2 points. Then to get everything right, I'm going to draw my, this free body diagram then goes over here. And the free body diagram on the previous page goes here. And once I have that, I can get all of the rest. So, like I say, 3.64 this way, 3.64 this way, that way, everything's got to be equal and opposite. And then this is 3.42 there. It's got to be 3.42 there, which is 3.42 there, like that. Once I have that, then I got this value here is right there, and that's compression. So it goes like that toward the point. That means this is in compression, which means this is pushing on this point. And we got these from the reactions. And basically, so we have completed this drawing like that. This is that drawing repeated. And then what do? I do the shortcut here. So how do I do the shortcut method? Basically, this is this. And then this is this. And this is this. So we get the whole diagram here. Okay, here's another one for you. Same thing. You can pick the nodes you want to do and solve this one. So pause the video and do this one. First, get the reactions. Of course, this is downward to the right. So I have downward to the right. 20 sine 80, 20 cosine 80. Take moments about point A. And again, we've done this a million times, but what do I get? I'll go faster. 3.47 times 2.57 clockwise. 19.7 times 0.936 clockwise. BY times 4 meters. Counterclockwise, I solve for BY. Take moments about B. I've got AY times 4 clockwise. I've got 3.47 times 2.57 clockwise. 19.7 times 3.063 counterclockwise. I get that for AY. I take the sum of the forces in the x direction. I only have that and that. AY is negative 3.47. I end up with this final free body diagram. I'm now going to use this to get my member forces. Let's look at point C. Here's my free body diagram. In other words, again, this is FBC goes like that. This is FAC goes like that. I have my angles. This is 40 degrees. This is 70 degrees. And I convert it. So the 20 is, again, downward to the right. So I have 20 cosine 80, 20 sine 80, downward to the right. This is downward to the left. FAC cosine 70, FAC sine 70, downward to the right. FBC sine 40, FBC cosine 40. I again take my sum of my forces in the x direction, I get that. sum of the forces in the y direction, I get that. So in other words, I'm just looking at my x forces for the x one. It's very simple. Once you have this diagram, things pop right out. I just take these for my y, and I get two equations, two unknowns. I'm not going to show them. I get these for those member forces. And again, what do we see? Well, notice they're both negative. That means they're both AC and BC are in compression. And then we're going to evaluate point B here. I already know what this member force is because I just solved it. It's 10.64 compression. So if it's 10.64 compression, it's going to go like that, 10.64. This is my reaction, I know that. So I look at this and I convert it to that. So it's going to be 10.64 sine 40 degrees, 10.64 cosine 40 degrees. Again, it's downward to the right. So I have downward to the right there. And then I have my FAB. I look at this diagram. I take the sum of the forces in the x direction equals 0. I solve for FAB. It's 8.15 kilonewtons. My final free body diagrams, again, what do I put on there? Well, I put the ones I solved for right there. Let's start there, and then where do we go from there? So I get the 10.64 there. I mean, this is the longhand. It means it's in compression. So this very clearly shows, I think if we look at this, it clearly shows this member is in compression because very clearly that 10.64 is. So this is the longhand way. And we solved that. So the only thing we need to add is this one down here. And since this is pulling on the node, this is pulling on the node. Since this is pushing on the node, this is pushing on the node. So I can get each node, and then I put on the reactions there. So take a look at this. I think you can all pause the video and look, and I think at this point you can get, and you clearly see from this diagram, you clearly see this member is in compression, this member is in compression, this member is in tension, and to do the shorthand method, you simply basically make these bigger. That's what it comes down to. So this goes, here. This goes, there. And this goes there. That's all you have to do the shorthand method. Okay, so that's for a triangle, and now you can see how to get each node in a triangle. Now we have a more complicated truss, and now I'm just going to say, okay, let's find just a few member forces, and how can we do that without solving this whole thing of node to node sort of thing? And there's some shortcuts we can do. And so if I look closely here, it says I want to get FDC, FCG, and FFG. So let's find those members to begin with. So DC is here, and CG is here, and FG is here. Okay? So notice, so they're all over in this region here, which helps us out. So first thing that we have to recognize is that if I want to find any of these member forces, I must make an imaginary cut through those members. I can't find the answer if I don't cut these things. If I don't cut those members, it's impossible to find the forces in those members. So in my analysis, at one point, I have to cut those members. Now, the first thing we're going to do is find the reactions. I'm not going to go through that because we've done it a million times. Here are the reactions right there. So what we're going to find is, now I'm going to cut all three members. So here are my three members that I needed to cut right there. So let's make a free body diagram that cuts all of them. So I'm going to come in here, I'm going to cut all these members like that. So if I can do a copy and paste, like I say, so I'm going to come in here and I am going to do my copy and paste. And what do I get out of it? What do I get? When I do it like this, it's, well, and I guess I was a little bit close on cutting those members, but what I did was when I cut member CD, well, you can see a little bit of it here. I have to show FCD or FDC, same thing. When I cut member CG, then I have to show the force for member CG. Well, there it is. And remember, we always draw these away like that. So we're using our skills in drawing a free body diagram that we developed early on. So don't forget those. I've shown where we're going to make the cuts. Now you have to do exactly that and replace everything with the forces. So we've done this and created this free body diagram from this. So I'm counting on you to be able to know that. So we've been able to produce this free body diagram. And now I'm going to look at this. What we didn't do previously is we drew the free body diagram, but we did not do any solving. So now we're going to do some solving, and you know, we're going to try to make it as easy on ourselves as possible. So let's look at this free body diagram right here, and we're going to take some moments. Well, we want to, ideally, we'd like to write a moment equation where we only have one unknown. So, you know, because we don't really like solving two equations to unknowns, and let's keep our life easier. If I take moments about point G, what happens? If I take moments about point G, oh, what do I see? That force goes through, that force goes through. So these two unknowns don't come into our equation. They're gone because it's times 0. And the only unknown left is this. So I'm taking moments about this point. So what do I have? I've got FDC times 3 counterclockwise. FDC times 3 counterclockwise. For this one, I've got 25 times 2, also counterclockwise. Minus 25 times 2. I solve for FDC, I get minus 16.7. Oh, that was easy. I didn't have to go through this point by point by point, you know, sort of tedious procedure. So we just saved ourselves a lot of work by doing it this way. In addition, now I can get FFG. How do I do that? Well, if I take moments about point C, remember we can take moments about any point we want. I can take moments about a point out here. I can take moments about a point out here or down here. Doesn't matter where we take moments about, but notice we'll make our life a lot easier if I get rid of those two forces by taking moments about point C. So moments about C, what do I have? Well, I've got this force and this force. So that's going to be FFG times 3 clockwise. And this is 25 times, notice the distance here because it's about point C, that times 4 counterclockwise. Goes into there. I solve for FFG, I get that. And then I can use this, I can take the sum of the forces in the y direction here to get FCG because it's the only unknown. Notice this those only act in the x direction, so they don't act in the y direction. If I take sum of the forces in the y direction, I can get that value. I need this angle theta, and that angle theta is, you can do it with, is the arctangent of 3/2, which is 56.3. So I then take this, what do? It goes upward to the left, so I have, in my free body diagram, I have an upward, I have a to the left, and the upward is FCG sine 56.3, to the left is FCG cosine 56.3. So I look at this, I take the sum of the forces in the y direction equals 0, I have the 25, I have the FCG sine 56.3, both of them are positive because both go upward, and I can find FCG is negative 30 kilonewtons. So, and what do I see? Here are my three answers, and this is a negative, so it means that that member is in tension. Or sorry, that means it's in compression. Tension is positive. This one is in tension, it's positive. FCG is negative, so it's in compression. So we have two members in compression. This one, and then the bottom one is in tension. And the values are listed there. So my final free body diagram, I can show that. This is in compression because it's acting toward the node. This is in compression, it's acting toward the node. This one is in tension, it's acting away from the node. And yeah, this explains it. Okay, so, and this explains more about how the negative number tells us that we have compression. Okay, so this is a problem for you using these same principles for this same truss. I want some different ones. I want FAE, FBE, FBC. Where are they located? AE, BE, and BC. So you want to do this with one cut. Figure out how I'm just going to give you a hint here. Figure out how you can make one cut and get all three of those members. Okay, pause the video, and you need to find the forces in those members. Okay, well, the cut that we would make would be right like this. I'm going to cut all three of those members. And so that's going to give me this free body diagram here. Again, you know, we may cut through that member, we cut through that member, cut through that member. We have to include all those loads. And so I'm going to show, I show them all as tension away from the node. We show them all as tension away from the node. We show them as that. And then if they come out negative, that means they're in compression. So now I have this free body diagram, and how do we want to solve this as easily as possible? So how can I do that? If I take moments about point B, for instance, I've gotten rid of, I want to get rid of some unknowns here. I got rid of two unknowns. I only leave one left if I take moments about B. So taking moments about B, what do I have? And I also get rid of that 40. So I've gotten rid of a lot of things here. And I'm only left with these three in my equation. So I'm going to have, FAE times 3 counterclockwise. I have 40 times 3 clockwise, positive. I have 5 times 2 counterclockwise, so it's negative. Put it into these expressions, I solve for, I get 36.7, it's in tension. I can take moments about point E. If I take moments about point E, what do I eliminate? I eliminate that load, I eliminate that load, all these loads, and I'm left with just these 3 here. So I'm going to have, take moments about E, I'm going to have 40 times 3 clockwise. I'm going to have FBC times 3 clockwise. And I'm going to have five times 2 counterclockwise. All those go into here, and I solve for that, I get that. And then I can take the sum of the force in the y direction equals 0. And what do I have in the y direction? Just these 2. They're both going down, so they're both negative in my equation. When I solve for them, solve for FB, I get -5. So again, if it's positive, it's tension. If it's negative, it's compression. Negative compression. So that is an easy way to get these forces without having to go point to point, which is sort of a pain. There's my final free body diagram. I just put in those forces. The tension goes away from the point, the compression goes toward the point, There's the compressions. Okay, so now FEF and FEC, you try to find those, FEF and FEC. You can use your previous results. Okay, so pause the video and find those two. Well, here's my free body diagram I'm going to take. That becomes this. I show FEF, FCE, FBC. Now we've found FBC before, right? I show it like that, but I already know what it is. I just want to make sure. Yeah, it's 36.7 compression. So I can use that. But I can take moments about C, for instance, to get rid of FCE. And I also get rid of that force there. So what do I have left? I've got this 40 times 3 clockwise rather. 40 times 3 clockwise. I have 5 times this total distance here, which is 4 counterclockwise. So it's negative. And then I've got FEF times that distance, which is 3 counterclockwise. Put them all in here. I get that value for FEF. And I can take the sum of the forces in the y direction. I guess I didn't show it well. But without showing it, I know that the y component there is going to be FCE sine 56.3 upward, right? So sometimes you can do these things in your head after a while. I've got that going downward. So FCE sine 56.3 upward minus 5 because it's downward equals 0. I get FC 6 kilonewtons. So this we got from the previous, so I didn't have to redo it. And there is my final free body diagram. Both of these are positive, so they're both tension going away from the point, going away from the node. Okay, FFC for this one. FFC, where's FF? There's FFC right there. This is an example. How do I do this? Well, now we're going to see some tricks. Sometimes it's fast to go with a node like this because some things are very visible. There's my free body diagram of that point. And what do I have? I have FFG going in that direction, FEF going in that direction, FFC going in that direction. And what do I see? Well, if I take the sum of the forces in the y direction for this, sum of the forces in the y direction, well, there's only one thing going in the y direction. That means it's 0. So FFC is called a zero force member. Now, if I look at this free body diagram just as it is, we cannot find these other two values. I can't do it from this free body diagram. So sometimes you'll create a free body diagram which you can't completely solve. But I didn't need, all I was asked for this one was, what is FFC? If it's a zero force member, then we don't need it, in a sense, in our truss. In other words, it's not being used at all. So in a way, I'd come in here and just erase it, eliminate that member. Don't be confused about what's going on up here. That's not going to tell you, well, you can see it's complicated. If I took the free body diagram of that point, I've got a lot of members, 1, 2, 3, 4, 5. I can't solve it completely if I have all those as unknown. So what we found now is that this is a zero force member by looking at this node. So I don't want to look at this node to get my FFC. I don't want to do that. I want to look at this node. So look at both ends of your member to determine, it's going to give you a clue as to which free body diagram you should take. Okay, here's another one. Homework, find FAC, FDC, FDE. So where are we looking at? FAC is this one. FDC is this one. FDE is this one. So I think you can come up with a free body diagram you can use to find those. Pause the video, go ahead and do it. I've given you the reactions, so you don't have to find the reactions for this. Well, the best free body diagram is right there. It becomes this free body diagram, and so now we use our skills here. If this is my free body diagram, I can quickly find FAC. Why? Because if I take moments about this point, I've eliminated these two. So I'm going to take moments about point D, and all I have are these. So I'm going to have 5.07. It's going to be clockwise times 5, and then 1.82, again clockwise times 2, and then I have FAC goes counterclockwise times 5, so it's negative. Right there, I can solve for FAC. Again, I can get rid of those, take moments about this point here, and get FDE. So I'm going to take moments about point C, And I have the 1.82 times 6 for that one, clockwise. And I have FDE, also clockwise, times 5. I get FDE is negative 2.18. And then I can take the sum of the, well, if I look at this, I can get rid of these two if I simply take the sum of the forces in the y direction equals 0. My theta is 51.3 degrees. You can see how to get that. So again, you need to do this a little bit in your head. Oops. And I know that the vertical here is going to point down, and it's going to be FDC sine 51.3. So I need to be able to do that in my head after a while. And so I have minus FDC sine 51.3. That's going upward, 1.82. And I could find my FDC. That I can draw my final free body diagram. Again, I can see that this is negative compression, so it goes toward the point, toward the node, and the others are positive, so they go away from the node, away, away, and there's my final free body diagram right there. And now we're going to do these, FBC, CF. So BC, CF, EF. Again, you, I think, can figure out a good free body diagram here. It's going to be this one. So pause the video here, do this. I'm now going to create this free body diagram. And again, I take moments about F here to get rid of these two. Leaves me only with FBC. And so I'm going to get FBC times 5 clockwise. .05 times 2 counterclockwise, negative. That gives me FBC. Then I can take moments about C. C is here, which puts me here. It gets rid of those two forces right there. And so I'm going to have counterclockwise FEF times 5, so it's negative. Counterclockwise 6.05 times 6, so that's also negative. And get that value, negative 7.26. I take the sum of the forces in the y direction, so I'm looking at this, sum of the forces in the y direction. Again, this goes down, and what's it going to be? It's going to be FCF sine 51.3. And so that's that going down. I have the 6.05 going up. That gives me my Fy. It's that. And again, I've got one of these is negative, so one of them goes to the point. The others go away from the point, the node. There's my final free body diagram. And okay, we keep going. So I'm just trying to get you to look at different free body diagrams and things. So now we want FEC, FBF, and FAD. Okay, so now There's no obvious free body diagram that you can take that cuts just those members. So how can we solve this? And maybe we can use, what we've learned before as well. And so let's take a look at it. So for these, the points may be the easiest way to do it. So if I take this one, let's do that one. So we do that one. Well, it gives me this free body diagram down here. And you can do some of this in your head. That, of course, is going to be 12 sine 65 going downward, 12 cosine 65 going to the right, and so doing it in your head a little bit, what do you see? So I'm going to have my going down is the 12 sine 65, so that's negative 12 sine 65. This is going downward also, so it's minus, and gives me that for that member. This is my final free body diagram. Notice it's negative, so it's in compression. It goes toward the point. I can take this free body diagram. Again, you should be able to do this in your head. My value beta ends up to be 68.2. And I can find FBF by taking the sum of the forces in the y direction. I can do the x direction as well, but chose to do the y direction. So again, we do this in our head. This is going to be FBF sine beta, sine 68.2, going upward. And then we have the 6.05 also going upward. And we solve for FBF. It comes out negative, meaning it goes toward the point. There's my final FBD for that one. And then I can take this one. And again, I'm basically doing, there are my reactions, so I have to show my reactions here. And again, I can take the sum of the forces in the y direction. Again, I could do the x direction if I wanted to, because there's only one unknown here. So this is going to be FAD sine 68.2 for the vertical, and then I've got the 1.82. And you can start to do this stuff in your head. This comes out negative, meaning it goes toward the point there like that. There's my final free body diagram.